So we are here in Alden Hall. This is the first in-person concert I have given for over a year, and I am thrilled to be here at WPI with my wonderful class, which you will be seeing over the course of this evening. I'm Professor Ibbett, and when I'm not teaching at WPI, I direct a nonprofit called Multiverse concert series, and we've been putting on concerts of music and art and science around Massachusetts. And I was thrilled to be invited to teach this new course, Music and Science at WPI. I think it's the perfect place to do it. You're all engaging in all these amazing science endeavors, and yet there's such a strong art presence at the school as well. So we've been working together. I introduced the students to some of the art science work that is going on around the world, and they have risen to the challenge and in 7 short weeks created their own pieces. Over the course of the evening, we're going to explore the birth of the universe, the richness and mutations of life, technology, emotions, and ultimately our fiery death at the end as entropy takes over. I hope you enjoy the show, and I'll bring up our first group, Sic Itur ad Astra. Let's have a round of applause.
Yeah, so the main idea about this piece is putting certain things about the Big Bang or the birth of the universe into perspective. When I say that the first era of the universe lasted 10 to the negative 32 seconds, what does that even mean? What does that sound like? What does that look like? There are a lot of these things that we're not able to visualize. Our brains aren't good at that. And the idea of this piece was to try and express these things as they're happening, this extremely eventful era of everything, of history, that lasted so short. We have an exhibition available to everybody that will be posted shortly after our presentation into the chat in the Zoom link. I highly encourage everybody to take a look at it. It has some very good facts and information, and it also has this song played at real time. So if you're interested in taking a look at that, I'd be more than happy to show it to you. But until then, here's the song.
and good evening, everybody. So my name is Jill, and I am very excited to share our piece with you today. I would like to start off by asking you to think about how your life has been affected in any way by cancer. I know that almost every single one of you will have some personal connection to cancer, such as a family member or a friend. Personally, I know that I have been affected in my life, so I think it's very important that this is something that is well understood by everybody. And not only do I mean understood through science, but also through emotion, which is why we've chosen a piece that helps dig deeper into the intricacies of cancer. The scientist in me is really fascinated by the formation and survival of cancer itself. There are a lot of complex processes that occur in order for cancer to form in the first place. And while the surrounding individual environment does play a part, I truly find fascinating that our own cell's ability to mutate into something that will negatively impact your own body. The effects of failure are really fascinating, and our body even has a really specific gene which contains the instructions to make one really specific protein sequence that is responsible for regulating all cell division and keeping any tumor formation at bay, and this is called the TP53 gene. Through this piece, we wanted to bring to the attention the errors that occur in the layers of the cellular process, such as amino acids, your DNA, and your nucleotides. We have done this through various methods, including musicality, vocals, spoken word, and after, we can also post a visual code where you can see the amino acids being parsed out into nucleotides, and you can actually see the data set that we chose to use. I hope you enjoy this piece, and I hope you have more questions than answers at the end.
Methionine, aspartic, leucine, serine, alanine, leucine, arginine, valine, glutamine, valine, glutamic, asparagine, valine, isoleucine, asparagine, alanine, methionine, glutamine, isoleucine, leucine, glutamine, cysteine, proline, isoleucine, cysteine, lysine.
On the very outside, all human functions from protein, which fuel our bodies. In order to create these proteins, humans have amino acid sequences. There are 20 of these amino acids, and they are the building blocks of life.
Lysine.
All amino acids are encoded in the genes of human DNA. Genes are made of human DNA, which are located in the chromosomes. Almost all human beings have 23 pairs of chromosomes, and they all have a unique purpose. These genes are made from strands of human DNA, which contain 2 polynucleotide coil chains. DNA is created from nucleotides, which all have 3 different parts: phosphates, sugars, and nitrate bases. There are 4 different nucleotides. These nucleotides are adenine, thymine, guanine, and cytosine. There are many different processes that must go correctly in the human body. And although most of the time the genetic processes are correct, sometimes there are changes. Genes can be affected by mutations, which is an alteration in the nucleotide sequence of a genome of an organism. There are many types of mutations, including point mutations, chromosomal mutations, and copy number variations. These mutations are capable of affecting every layer of the human body, from the nucleotides to the proteins. As the nucleotides are changed, the order of which the nucleotides are matched to the mRNA affects the rest of the process. Each amino acid begins and ends with a very special mRNA codon, which specifies which amino acid is created. When the nucleotide order is changed, so is the amino acid order, which affects the creation of proteins. As genes are mutated, the proteins are affected and the body no longer knows how many cells to create. As more genes are mutated, more amino acids are changed and more cells are added, and cancer can be found. Cancer is usually caused by genetic mutation, but is often not found or understood easily. The drastic differences between cancer and non-cancer cells can be seen in many different ways, through MRI, or X-ray, or reading of scientific papers, or learning in class through both music and science.
Hello, we are How Are You Feeling Today? We are excited to share our final piece with you. It has been the culmination of about 4 weeks of work. And when we first went into this, we were really trying to find a piece where we could use each of our individual skills. And I think we've actually managed to do that. I started out this piece by using my musical skills to compose a new melody on my cello. And the real goal here was to find a melody that could work for multiple emotions.
So after Eslin made the melody, I reharmonized it in Ableton, and I did that to convey about 5 different emotions. I ended up making a separate piece for each emotion, and then I recorded and chopped up the audio and gave it to Min to incorporate into his facial recognition program.
I then took these sound bites and put them into a program which reads a person's expressions. There was a lot of challenges we faced while putting this piece together, but it came together nicely. We hope that you enjoy it, and without further ado, here's how you're feeling today. Thank you.
Hello, my name is Natalie Matthews, and this is Nathan Nguyen. And our other teammate, Jared, is not here right now. He couldn't make it. But our composition is called Transpiration. For this project, we chose to compose a piece presenting 4 stages of the water cycle: precipitation, percolation, evaporation, and condensation.
We would like to say thank you to Professor Ibbett for helping us throughout the project and creating this amazing concert. And I hope you guys enjoy our piece. Thank you.
Water vapors pour down due to wind or temperature change. Droplets combine to make bigger droplets. Low temperature at high altitude. Droplets lose heat energy and fall. Water runs over the surface of the earth, bringing the soil and minerals along with the stream. The runoff combines to form channels and rivers that leads to the lakes, seas, and oceans. Water from oceans, seas, lakes, and rivers absorb heat energy from the sun, turn into vapors. As water evaporates, it reduces the temperature of the water bodies. Water rises up in the atmosphere, turns into tiny particles of droplets because of low temperature. Particles come close together and form clouds and fogs. Vapors fall down to create rain, and the water cycle starts all over again.
Hello all, my group including Nikki Harrison and myself. Hello all, my group including Nikki Harrison and myself composed a piece over the last few weeks called Secret Slope. We gravitated towards the ski resort, daily snowfall and snowpack data because our entire team has a strong connection to skiing and the mountains, which while made us very invested in the piece, did not really help when identifying a proper message.
In the end, we wanted to most clearly express the changes in weather of the mountains by mapping the data to the E minor scale and using it as a guide for developing a piece that allows the listener to experience the feel of the mountain, as well as the musical pattern of the data itself.
Using the mappings of the data, a high-pitched piano key is played to communicate the level of average snowfall for the past 10 years. We then use the mapping as a basis for the rest of our piece. The guitar solo follows the same mappings as the piano, but provides variations to give more life and emotion. While sounds of wind and harmonic wind chimes play during especially hard snowfall. We hope you enjoy listening.
Thank you, everyone who was able to attend our Sound of Science concert this evening, especially since we're all on Zoom. We really appreciate all of you for coming out and supporting us. My name is Ryan Gillette, and with me are Emily Pollock and Kome Kadoya. I would also like to thank Sophia Strano for assisting us in our recordings. We have worked very hard over the past month to bring this vision of ours to life. However, before we discuss our project, I would like to give a personal thank you to Professor David Ibbett. I have had the opportunity to be a part of 3 of his classes now, and I've enjoyed every single one extremely. I've learned so much about the music creation process. Without him, my drive to create music would have most likely just disappeared. Fun fact, today is the first time I'm meeting him in person, although I've known him for the past 12 months.
This composition uses sonified data from the coordinates of a hyperbolic paraboloid, which is one of the theories for the shape of the universe. We use this sonification to develop a piece representing the possible fate of existence and what could happen if the universe stops expanding.
To represent this data in the real world, we 3D printed a disk generated from sonified data and pointed a laser at the point of the disk that we're currently sonifying. We also have a projection mapping sync to the music to make it visually interesting.
Once again, thank you for coming to our virtual concert tonight. And now for our final piece of the evening, critical density.
At first, there is nothing. No light, no darkness, no space. Nothing there, nothing missing. No matter, no time, no place. A blinding light, infinitely bright across rapidly increasing distance, filling the entire space of existence. Heat radiates out from a single spot, unimaginably hot, agonizing heat, an infinite burn, beginning matter swirls, churns. Millions of years pass and the light slowly dims. Through millions of years, the heat slowly simmers until all that is left is darkness and cold and winter. Freezing cold. Things begin to settle. Objects appear. Stars, rocks, metal. Space expands and expands. The universe expands. slowing, slowing, slowing. Stopping. Critical density. The universe recognizes its immensity. Gravity plants its feet and things begin to retreat. Heat concentrates, stars collide. Matter evaporates, black holes consume. The heat is infinite. Universal collapse. And in the end, there was